Okay, for our today's lab topic is MIPS, instruction format and addressing modes. Okay, class. Okay, I give you some tips. So this is a very popular question in exam, right? Okay, so you should be able to list the instruction format. Okay, and should be able to give an example of instruction. Okay, for each of the addressing modes. Okay, right? So I hope you take note. Okay, what I have mentioned just now. Okay. By the end of this section of practical, students should be able to understand different types of instruction formats and its application. Secondly, understand different types of addressing mode and its application. Okay. Finally, able to demonstrate constant usage in instruction. Okay, right? So read through about half a minute. We will continue in short while. Okay. Okay. Introduction. Unlike other architecture, okay, right. And my MIPS have only a small number of ways that it computes address in memory. Okay, the address can be address of an instruction for branch and jump, or it can be an address of data. Okay, for load and load is store instruction. Okay, instruction format is how the instruction is put together, whereas addressing mode is how the address of an operand is determined. Okay. Okay, for instruction formats, okay. Okay, this is the most important one. So please take note. Right. Okay, the three most important types of instruction format. Okay, right. The first one is the R type. Okay. Okay, what is R type, class? R is for what?
Register.
Still very good. Okay. Okay, instead of R, what are the other two instruction format that we have? Instead of R type. Apa lagi kita ada? What else?
I type.
I type. I is for what, class? I is for what? Immediate. And the other one is?
Jump.
Jump or J type. Okay, so you're excellently able to understand the exam question. Okay, right. Okay, the first one is the R type, which is the register type. Okay, this group contains instruction that do not require immediate value. Okay, so in other words, for R type instruction, okay, all segments of instruction only consist of register. Okay, okay, this include arithmetic and logic instruction. Okay, okay, with all operands in register. Okay, or shift instruction, or register direct jump instruction, JAL or JR. Okay, for R type instruction, okay, if let's say you are doing, okay, let me give an example. Okay, if you are using instruction such as lagging, hold on. Okay, add or sub. Okay, right. So the opcode will always be 00. Okay, so if you are using R type instruction, okay, normally the opcode will always be 00. Okay, in which the opcode is the one at the front. Okay, for this, I think I believe I better open the MIPS green sheet. Okay, so you should be able to refer to the MIPS green sheet lah, right? Okay, so for R-type instruction, okay, normally in the front, okay, it is will always be 0000. Okay, okay, the opcode, okay, the opcode at the front. Okay, so the 5 digits or 5 bits in front will always be 0000. Hold on, let me use, okay, this one correct. Okay, so for R-type instruction, okay, okay, the opcode will always be, okay, consists of 5 bits of 0. Okay, 0 0 0 0 0. Okay, so this will indicate this is an R type instruction. Okay, class. Okay, are you clear so far, class? Is it clear? Have you copy the one that I have key in just now, which is this one? Okay, right, for R-type instruction, the opcode will be always all zeros. Okay, in which consists of how many bits, class, for opcode segment for instruction format? How many bits, class? How many bits for opcode?
6 bit.
Okay, 6 or 5? 26, 27, 28, 29, 30, 31, 6 bit, right? Okay, so you have to count how many bits. Okay, so you have about 6 bits of opcode. Okay, right? Okay, so this is the format being specified lah. Okay, so you have to count the number of bits, okay, from 26 until 31. Okay, so we have 26, 27, 28, 29, 30, 31. 6 or 5, class? 6 bit or 5 bits for opcode? Okay, remember back the lecture that we have learned previously. You still remember how many bits for opcode? 5 or 6? Okay, I want you to revise back. 5 or 6, class?
6 bit.
Okay, 26 to 31 lah. 26, 27, 28, 29, 30, 31. 6 bit, right? Okay. So in other words, okay, this is the bits whenever it is an R-type instruction. The opcode will always be all zeros for the rest of the 6 bits. Okay, right? Okay. So to determine what is the function, whether it is add or sub, okay, it will depends on the function segment here. Okay, let's say we are using add. Okay, let's say we are using add instruction for register instruction. Let me browse to the top. Okay, let's say we are using add. Okay, so the function segment is consists of 20. Okay, okay, the code, okay, the hex code for add is 20. Okay, therefore refer back to the instruction format. Okay, so all register type instruction, okay, the opcode will be all zeros for the 6 bit. Okay, but to determine whether it is an add or sub, it will based on the function segment here, func here. Okay, so you can see here for add. Okay, the function is the machine code or hex code for add is 20. Okay, therefore, okay, so here you put it as 20 hex. Okay, 20. Okay, so I better make it smaller. Okay, 20. Okay, so 20 in the base of what? Is it hex or is it decimal or what? Class 20.
Hex.
Hex, right? Okay, right. So now we want to put it in the form of binary numbers because we consist of how many bits for function, class? How many bits? for function segment? From bit 0 until bit 6. 5 or 6?
6.
6, right? Okay. So you can count. So basically, the green sheet is just like a cheat code lah. I mentioned to you yesterday, is it? Okay, right. So the MIP sheet is just like a cheat code ataupun a formula, but you need to be able to know how to use the MIP sheet. Okay, so from the hex number, you convert to equivalent binary. Okay, right. So how to convert from hex to binary? Okay, 1 hexadecimal digit equivalent to how many bits, class?
4.
How many bits? 4, right? So we have, what about 0 hex? We convert to binary, what we get? 0, 0, 0, 0. Okay. Okay. What about 2? What do we get for 2?
0, 0, 1, 0.
0, 0, 1, 0. Okay, but if we count the number of bits now, okay, how many bits that we have shown here? Is it 6 or 8?
8
How many?
bit.
Okay, how many bits that required for function segment? 6 or 8?
6.
Okay, therefore you can omit lah. Okay, the leading zeros. So it is 0, 0. So actually the leading 0, okay, will be shifted or will be given to the shift amount. Okay, so if you count here, okay, so supposedly for 2, if we change to a binary, you will get 0, 0, 1, 0. Okay, but because of the function segment only requires 6 bits, okay, therefore you just pick only the 6 bit. You count the 6 bit from the LSB. Okay, so the remaining bits you derma lah, or you infarct, or you give to shift amount. Okay, can you get it? So if you count all together, equivalent to 8 bits lah. Okay, are you clear, class? Is it clear?
Yes.
sir.
Okay,
Yes.
tak boleh bawa So actually we need only the 6 bit, so the rest of the additional leading 2 bits we give to shift amount. Okay, so this is what it tells you that, where is it? Let me open again. Okay, for R-type instruction, the opcode is always 6 number of zeros. Okay, right? Okay, so this is the detailed format for R-type instruction. Okay, so we have the opcode. Okay, we have the RS, okay, RT, RD, shift amount, and function. Okay, so this is the format that equivalent to the one in your MIP sheet lah. So if you want to have a look, I can open side by side, but little bit smaller lah in size. Okay, let me show you. Okay, so let me enlarge the size here. Real small. Oops, 125. Okay. Okay, as you can see here, this one I'm supposed to make it smaller. Okay. Okay, compare the MIP sheet and your lab notes. Is it similar for R-type instruction, class? Is it similar? Sama tak? Is it the same? So the the rightmost is the function. Okay, function which is a 6 bit. Okay, after the function will be the shift amount, sham. Okay, shift amount 5 bits. Okay, from bit 6 until bit 10. Okay. And then we have the RD, which is the destination register. Okay. Okay, RD, how many bits, class? RD. How many bits?
5 bit.
5 bits, right? Because you count from bit 11 until bit 15. 11, 12, 13, 14, 15. So that's why we have there 5 bits, right? Okay, what about RT or first target register? How many bits, class? How many
5 bits.
5, similar. So all register, the size for the segment is 5 bits, always 5 bits. And the leftmost, which is the opcode. Okay, the opcode will, if it is a register type instruction, the opcode will always be 0. Okay, class? Okay, are you able to digest, or are you able to appreciate the MIP sheet? Are you able to understand the MIP sheet, class?
Yes.
Now?
Yes.
Okay, so I stress to you again. Okay, so the MIP sheet is actually just like a cheat code when you play games, right? When you play games, you have a cheat code, right? Or you have a formula, kan? Kalau dalam SPM, you ada formula yang you boleh bawa, kan? Tapi it is no point you bring 100 pages of formula, but you're not able, or you didn't know how to use the formula. So this is how actually you have to know how to extract the MIP sheet. Okay. Okay, same goes to here. I give you an example. Okay, so please take note. This is very important question in exam. Okay. Okay, let's say our RD. Okay, so please bear with me. Okay, please follow me. Okay. Okay, let's say your RD is T1. Okay, you refer to the one that I show here. Okay, okay. So if it is T1, okay, what is the number class for T1? $sign T1. What is the number? Now I show you the answer already. Okay, for T1, what is the number? $sign T1 is equivalent to which number of register? Quick class. Okay, so I write here $sign. Okay, T1. Okay, make it smaller. Okay, right. Okay, you refer to the MIP sheet. Now I want to teach you how to use the cheat code. Okay, okay. Refer to this register name and numbers. Okay, T1 is equivalent to what register number, class?
9.
9.
9, right? Because T0 is what? Register 8, right? Okay, so for for register, okay, how many bits for register or RD? How many bits?
5.
5, very good. Okay, right. Okay, so the number is for T1, okay, the number of register is 9, right? So straight away you know the answer of the field for RD. Okay. Right, so okay, the number 9, okay, is in the form of decimal. Okay, okay, so I stress it again. All this number is actually in the form of decimal. Why? We have 26, 27, 31. It is not possible hexadecimal, right? Because hexadecimal is only until 9, and then A, B, C, right? For 31, okay, it is a decimal number. Okay, so fill up the field for the RD, for the register RD, destination register. Okay, what is the binary equivalent value for RD, class? In decimal, the value is 9, right? Am I right, class? Betul ke?
Yes.
Okay. From decimal 9, convert to binary. What is equivalent number in binary?
1001.
0, 1. Okay, right. So now you almost get the answer. You almost get the full mark already. Okay, is it is it enough, or it is not complete yet? How many bits for RD, class? 4 bits or 5?
5.
Oh, so what should we do in order to make it 5 bits?
Add 0.
Add 0 where? To the MSB, right? Am I right?
Yes.
To the leftmost, right? So you just add 0. So now you have the full marks. You get the full mark. You get the way how to answer the question, class. Get it, class?
Yes.
Yes.
So this is how you answer the question, right? It is simple as that. Actually, the green sheet is already a cheat code that you should be able to exploit it to get the answer. Okay, now you can copy for a while in half a minute. Okay, you can copy this one. Okay, right. Any questions so far? You can ask if you have any. Okay, Mr. Faisal, are you with me, Mr. Faisal? Faisal? Okay, it's not here. Okay. Okay, as simple as that lah. Okay, right, the shift amount. Okay, normally shift amount. Okay, shift amount, how many bits, class? Shift amount, how many bits? 6, 7, 8, 9, 10, 5 bits, right? So you can complete it as 5 bits. Normally, shift amount will be 0 lah, unless we have the shift SLL, shift right, shift left or shift right. Else we just put it as all zeros. Okay, right. Okay, now you already get the full mark lah. Okay. Okay. You copy first in half a minute. Okay, class. Okay, so far so good, class. So far, okay. Class.
Okay, sir.
Okay, okay. So bagus lah. Okay, kita boleh pergi laju sikit. Okay, the other one is the I type instruction, which is immediate. Okay, right. So kita tengok. Okay, sekarang dah 12 suku. So I try to go through with you as soon as possible. Okay, okay. The I type is for immediate type. Okay, where is the highlighter? Okay, okay. It consists of immediate operand. Okay. Okay, a branch instruction. Okay, load and store. Okay, okay. All the instruction that require permits or involved with immediate addition or performing a branching. Okay, load and store will involve immediate instruction. Okay, in MIPS architecture, all memory access are handled by the main processors. Okay, and so on. Okay, so this is the format, instruction format for I type instruction. So we have the opcode. Okay, we have the register source. Okay, and then we have the RT, right? Okay, RT is the register that we want to refer. Okay, so that we can perform a branch and so on, and then we can have the immediate value. Okay, right? Okay, this is also the important type of question that could be asked in exam. Okay, please take note. Okay, so in exam, they could give you some question like this. Okay, there are 3 types of instruction format. Okay, list the types of instruction formats. Right. So just now you able to list down the register formats lah. The first one is the R type. Second one is I type. Finally is the J type. And then the question continue. Give an example of each of the instruction format. Right. Therefore, you can give the example for R type instruction such as add. Okay, such as add instruction. Okay. Okay, and then the I type instruction. Okay, you can use such as ADI. Okay, right. Okay, and finally for J type instruction. Okay, the example such as we can use the jump J instruction. Okay, right. So this is the type of question that potential being asked in exam. Okay, so now we continue with the J type instruction. This group consists of 2 direct jump such as J or JAL. Okay, right. Okay, this instruction requires memory address to specify the operands. Okay, okay, J type instruction use opcode 0001. Okay, so sorry. So if you are seeing a J type instruction, okay, okay, so the opcode for a J type instruction will be 0001. Okay, because the opcode segment is 5 bits. So when you see the opcode 0001, okay, so this one we can, okay, enough or not yet? Not yet, right? We need 5 bits. Okay, so we have one more zeros. Okay, so this one we call as the J type instruction. Okay, right. Okay, so this is the type, the details for the instruction type application, right? Okay, for instance, we have the add RD, okay, RS, RT. Okay, anybody can tell me for bonus mark, what is the meaning of this instruction? Anybody want to tell me what is the meaning of this instruction? Add RD, RS, RT. Okay, quick, tell me what is the meaning of this instruction? Anybody? Please recall back what you have learned previously. What is the meaning of this instruction, class? Okay, anybody? Before I call anybody to give the answer. Quick, we want to finish as soon as possible.
Sir, may I try?
Okay, try. Nama?
Aida.
Aida, okay. Cuba Aida.
Add RS and RT.
Okay.
And store the value in RD.
Excellent, Aida. Okay, so this is the correct way, and the answer being given by Aida is the correct answer, but this is the correct way to answer this type of question. Okay, so RD is equivalent to RS plus RT. Okay, but if you see here, thanks Aida. Okay, whenever we want to rearrange in the form of instruction format, okay, depends on the bit segment. Okay, okay, there will be a cross. Okay, let's say RD, this one RD is the leftmost, right? But whenever you arrange in the form of machine language, right, you put RD as the rightmost register. Okay, class, can you get it? Can you see here the cross? Okay, remember that I have shared you in my you learn. What's that? This one. This one. See here. Okay, the instruction is RD equivalent to RS plus RT. So whenever you want to arrange in accordance to the instruction format. Okay, so the RD will be the right handmost register. Okay, and RS will be the field after the opcode, and RT is the field after the RS. Okay, is it clear, class? You can snapshot this one. Are you clear?
Yes.
Because we want to determine, okay, the machine code or the hex code, right? So in order to rearrange the machine code or hex code, okay, so this is the formatting. Okay, even though you write it as RD equivalent to RS plus RT, so whenever you want to break up into the machine code, into the specified instruction format, okay, the RD is the right handmost register. Okay, the left handmost register next to the opcode is the RS, follow with the RT. Okay, class. Right. So I hope you are clear with it. Okay. So that's why here we have the RD is the rightmost register. Okay. Follow with RS. Okay. RS and RT. Right. Okay. So this is actually the bits lah. The bits number 0 until 5. This one is 6 to 10. Okay, kalau if you look by yourself, maybe you confused lah. But this one is 11 to 15 for RD. Okay, for RT, it is 16 to 20. RS is from bit 21 to 25. And opcode from bit 26 to 31. Okay, right? All right. Okay, the following example is the RD, RT, RS. Okay, just now when you refer to the add, okay, there will be a cross, right? RD, RS, and RT. Okay, what about RD? Do we have a cross or it follows the similar arrangement, class? Is it follow the similar arrangement or is it cross? Okay, right. So I want you to you investigate here. Okay, as the first one I have shown you. So for the next one, okay, you can refer to the notes, right? Okay, the following one is the branch, okay, which is the branch equal. Okay, all right. For branch equal, okay, we have here branch equal. For branch equal, okay, RS will follow, RT is also follow. Okay, right? Okay, and the opcode is the opcode for branch equal. Okay, right? And the immediate value, okay, will be the rightmost field. Okay, right? So when we have the branch equal, okay, so actually what it will do, it will compare. Okay, it will compare the content of register RT with the content of register RS. Okay, if the content is equal, okay, they will jump to this immediate value, right? Okay, so later on we will see some example. Okay, right? So actually it will compare the content of register RS and RT. Okay, so I can give you one simple example. Okay, so let's say $sign RS, okay, and $S sign. Okay. Okay, let's say the content of $sign RS is 9 hex. Okay, and the content of register RT, okay, 8. So 9 lah, 9. Okay, we make it as 9 first. Okay, now we are referring to the content of register. Okay, is it content of register RS equal to the content of register RT, class?
Yes.
Is it similar? Okay, if it is similar, they will branch. They will call the IMM function at the bottom here. Okay, but if let's say the content of register RT is 8, okay, is it 9 equivalent to 8?
No.
No. If no, they will follow the following statement ataupun following instruction under branch equal instruction. Let's say after that we have the add. Okay, add. Okay, RD, RS. RT. Okay. Okay. Close. Okay, let's say, okay, the content of register RS is 9, RT is 8. Okay, when the assembler, okay, pass the branch equal instruction, they will compare the content of register R8 and R9. I ask you again, is it similar or different?
Different.
Different. So if it is different, will it call function immediate? I have forgotten to insert the function immediate. Okay, so down here, okay, we have one function. Okay, IMM. Okay, you have one function immediate. Okay, okay, will it call immediate, or will it continue the following instruction under branch equal? Which one? If the content of register RS is 9 and the content of register RT is 8, will it call immediate function? Okay, or
No.
will it continue with add?
Continue with add.
Excellent. Continue with add. Why? Because the condition is not equal. Okay, but if you put it, okay, if the value of register RD is 9 and sorry RS is 9 and RT is 9, okay, if the content of register RT is 9 and RS is 9, okay, therefore they will perform the branch. Okay, will perform the branch, then we'll call immediate function. Okay, so this is the function of branch lah. Okay, so in C++, okay, normally we simplify, or we can have a function if statement. Okay, so in C++ we use the if statement. Okay, then in assembly language we use the branch function. Okay, so the PC update the branch to find out the condition if it is true. Okay, so the one that perform this operation is the ALU lah. Okay. Okay, so the source operand fetch. Okay, so the ALU will decide, okay, whether to perform the branch or to go on with the following instruction. Right? Okay, for branch instruction, okay, they not involve any memory access, and it is not involve any register write. Okay, that's why you can see here, memory access is none and register write is none. Okay, because nothing being written in in register and memory after you perform branch equal. Okay, right. Okay, the following one is the load. Okay, load word RT immediate value RS. Okay, so don't worry much, I just give you an overall view lah. Okay, right. Okay, the immediate value, this one could be any value lah. Okay, right, so RS is the content of register. Okay, right, so this is the format, okay, for load instruction. Okay, so we have the opcode, we have the RS and RT. Okay, so the details for the load we will discover afterward during the next section. Okay, okay, PC update, there is no update beyond the normal increment. Okay, okay, source operand fetch, the two source operands are RS and signed extended immediate fields. Okay, so actually by performing load word, okay, we are copying, okay, the content of memory location pointed by the RS plus with immediate value. Okay, and the result will be stored in register RT. Okay, right, the ALU operation, the two source operands are added to get the memory address. Okay, so actually the immediate plus with RS, they will find the specific memory location, and from that they will copy the content of that memory location. Okay, they will save into RT. Okay, so I just give a brief idea lah. Later on we will see in example. Okay, so memory access, a memory read control is sent to memory. So whenever we are using load word, okay, memory access will involve. Okay, the result of ALU is sent to memory as the address. Okay, right. Okay, the other one is the store word. Okay, store words means that, okay, we will write the data. Okay, right. So for the PC update, there is no update beyond the normal increment. Okay, source operand fetch. The two source operands are RS and sign extended field. Okay, so we will store into memory. Okay, so we'll store from register into memory. Okay, memory access. Okay, for store word also involve memory access. Okay, in which the memory write control signal is sent to memory. Okay, the result from ALU is sent to memory as the address. Okay, the content of RT are sent to memory as the write data. Okay, as a comparison. Okay, as a comparison. Okay, load word is actually we are loading from memory. Okay, we save the data in memory into a register. Okay, as a conclusion. For store word, okay, we are copying the content of register into memory. Okay, so I don't have an arrow here, so I just use my cursor. Okay, so you can highlight, or you can use your pen to show the flow. Okay, for a load word, okay, it is actually we are copying the content of memory location into register. You can draw an arrow here from the memory into register. Okay, for store word, okay, we are copying, okay, data from register into memory. Okay, you can draw a line. Okay, you can draw an arrow to show, okay, the data being stored from register into memory. Okay, so that is the reason between load word and store word. And for both operation, memory access involved for store word and load word. Okay, right. Okay, and the other one is the register jump. We discover later lah, right? Okay, and this one is JAL. Okay. Okay, this one also we will discover later. Okay, because we want to go to the most important parts. Okay, class. Okay, sorry. The next most important things to remember is the addressing modes. Okay, okay, we recall back in half a minute. Okay, I want you to recall back. Okay, what are the example of instruction type that we have? How many instruction type that you have, class? Just now?
3.
3. Okay, what are the instruction types?
R-type,
R-type, lagi?
I-type,
I-type and
J-type.
J-type. Excellent. Nama?
Shavika.
Shavika. Okay. Sekarang, okay, selain pada itu, the next popular question is give an example of addressing modes. Okay, so the answer is the first addressing mode is register addressing. Okay, second one is immediate addressing. Third one is PC relative addressing. Okay, fourth one is base addressing. And finally, pseudo direct addressing. Okay, right? So I go through with you in general. Okay, right? So for register addressing, a source destination operand is specified as the content of one register, from register 0 until register 31. 32 register all together lah for MIPS register. Okay, immediate addressing. Okay, they will have an immediate value embedded into the instruction. Okay, so when we want to insert any value, for instance, number 9, number 8, so it is an immediate addressing, right? The third one is the PC relative addressing. A data of instruction location is specified as an offset relative to the incremented program counter. So this one we'll discover afterward. What is PC relative addressing? Okay, base addressing, a data or instruction memory location is specified as a signed offset from register. Okay, finally, the pseudo direct addressing, the memory address is mostly embedded in the instruction. Okay, we go on to the first type of instruction, which is the most easier one. Is the register addressing, right? Register addressing is the simplest addressing mode. In this category, both of operands are registered. Okay, so we can see here all are registers. Okay, instruction will be executed faster. Okay, so please bear in mind, if you run register addressing, okay, it is the fastest instruction type. Okay, so this is an example for instruction addressing, very simple. Okay. Okay. Okay, so this is the example of instruction addressing. Okay, so let's discover together. Okay, so this is also a popular question in exam. Okay, so let put it side by side. Where should I put it? Here. Okay, and I open my Microsoft Excel. Sorry. Okay, this one I copy first. Okay. Okay, you can follow my steps. You can follow my steps. You can draw the. I'm supposed. Okay, I better copy this one. Okay. Okay, class. You may follow my steps. Okay. Okay. Now we want to appreciate the machine language, right? We want to appreciate how to do the conversion from assembly language to machine language, right? Okay. Now I want you to refer to this example. So should I make it 100% or? Okay, right. Okay, hold on. Let me copy this one again. I'm supposed to copy this one. Okay, this one. Still copying this one. Right. Okay, now I wanted to show you how to answer the exam question, right? Okay. So what you see here, make it a little bit smaller, maybe 5%. Okay, right. Okay, can you appreciate this diagram, class? Okay, this diagram is showing what, class? The op, rs, rt, rd, shift amount, and function. Showing what?
Register.
The instruction format. Okay, so this is what we call as instruction format, right? So this is how to convert from assembly language into machine language, right? Okay, class, very good response. Okay, right. Okay, so we can see here. Okay, okay, I want to teach you step by step. Okay, for this one, okay, the function is add. Okay, the function is add. Okay, right. Okay, so I think I better delete this one. Okay, right. Okay, so we have a function is add $sign T0, T1, and T2. Okay, what type of instruction is this? R, I, or J? Which one?
Type.
I. Is it I? Class?
R.
R. Okay, so if it is R, what about the opcode? Okay, opcode all zero. Am I right? Betul ke?
Yes.
Okay, so you fill up, the opcode is all 0. 1, 2, 3, 4, 5. Okay, right? Okay, and normally shift amount. Okay, opcode, how many bits, class, for opcode? 5 or 6?
6.
6. Betul tak ni?
6.
Betul ke tak cukup?
Tak cukup.
Cukup
You have
satu.
to add another 0. Okay, right? Okay, right? Okay, so this one we can delete first. Okay, right? Okay, shift amount. The easier one first lah. Shift amount, how many bits class? Shift amount.
5.
5, right? So you put it as all zeros. Okay, so now you want to discover the function. What is the value for this function, right? Okay. Okay, so now what is the function for this register instruction? Add, right? Okay, so you refer to the MIP sheet. Where is my MIP sheet? Okay, you refer to your MIP green sheet. Okay, for add instruction. Okay, what is the hex code class for add instruction? What is the function value for add instruction?
0.
20.
0, very good. Okay, so you put this one as 20. Okay, you put it as 20. Okay, okay, 20. Okay, 20 in the form of decimal or hex?
Decimal.
Decimal or hex?
Hex.
Hex,
Hex.
kan? Okay,
Hex.
tengok kat sini dia hex ke decimal? Kata hex kan, nampak? Hex ni. Can you see?
Yes.
20 hex. Dia bukan decimal Boleh Is it clear class?
Yes.
Clear? Right.
Yes, sir.
So you put it as 20 hex. Okay, therefore you have to convert to binary. Okay, so I insert another field to make it quick because we want to have Friday prayer. Okay, so this one I put at top. Okay, 20. Okay. Now for 20, okay, hex. Okay, we want to convert to equivalent binary numbers. Okay, convert 20 to binary. What do you get? You'll get
0, 0, 0.
0, 0, 1,
you
0.
get 0, 0, 1, 0, and then
0,
0,
0,
0, 0, 0. Is it correct, class? Correct? Betul ke?
Yes, sir.
Okay. For function, how many bits for function?
6.
Required 6.
6.
But for the time being, we have how many bits? 8 or 6?
8.
8. Or you remove the leading zeros. Okay, leading zeros. Okay, so that's why you have 1, 0, 0, 0, 0, 0. Okay, right? Okay, so the rest you will be given to shift amount. Okay, right? Okay, so this one is for T0. Okay, okay. Now you find out from the MIP sheet. Okay, T0, which is the RD. Okay, for T0 is for register number what class? T0. Refer to RT. Register number what? Tak ingat. Okay, tengok sini Kalau tak ingat, refer to this. Okay, let me browse through very fast. Okay, T0. Check T0. Okay, T0 number what?
8.
8, right? So register 8. So what about T1? Register number?
9.
9. T2 register number?
10.
10. Okay, so ingat jangan lupa Okay, so RD, okay, which is you see here it is a crisscross. Sorry, it is cross. Okay, so T0 will go to RD. So we determine the RD first. Okay, so what is the value for T0 class? Register number?
8.
Register number?
8.
8. So what is 8 in binary class?
1, 0, 0, 0.
1. Sorry, 1, 0, 0, 0. Okay, but for RD, is it 4 bits or 5 bits class?
5.
5.
5. So what should you do now?
Add 0.
Add 0 to the
Add 0.
MSB, right? Okay, so now you get it. Okay, so for RD is register 8. Okay, what about RT? RT is T2, right? Okay, RT, what is the for T2, what is the register number for T2 class? Register what?
10. 10.
10. 10 ke 9? 10 Okay. Okay.
10.
Okay, now you help me to convert to the equivalent field in binary. What is 10 in binary?
1010.
1010. Is it correct, class? Is it correct?
Yes.
Yes.
Okay, same. Is it the same with this one?
Yes.
Okay, now I want you to think about RS. Okay, RS. RS is register what, class?
9.
Register 9. Okay, help me to fill up this one. Okay, so what should be the value we should insert here? 9. 0. Then
100.
1001.
1. Excellent. Right? Okay, so now you have all these bits. Okay, count all together. How many bits altogether, class? How many bits altogether? This one is 6 plus with 5 plus 5 plus 5. Okay, 15, right? Okay. Okay, 15 plus 6 berapa? Okay. Kalau you tambah semua sekali, when you add up all this number, how many bits altogether, class? How many bits? Okay. How many
32.
bits? 32. So it is equivalent to 32 bits of one register. Okay. So means that okay, one register can hold one instruction. It will consist of 32 bits. So this is the popular question being asked in your exam. Are you clear, class? Is it clear? Okay, what about the opcode? Forgotten about opcode. Opcode for register type 0, right? Am I right?
Yes.
Okay, so that's why we have 0 here, right? Okay, so everybody clear to answer this type of question?
Yes.
Okay, very good. So we can go very fast. Okay, so now we move on to the following one. Okay, it is almost 1 o'clock already, which is the immediate value, immediate addressing. Okay, immediate addressing, the operand is the constant within the encoded instruction. Similar to register addressing, instruction will be executed faster because it does not involve memory access. Okay, however, the size of operand is limited to 16 bits. Okay, the jump instruction format also fall under immediate addressing. Okay, so we have an example of immediate addressing. Okay, for instance, we have the ADI. Okay, so for immediate addressing, it's also a very fast instruction, right? Okay, so what is the meaning of this instruction? Anybody want to tell me? ADI $sign T1, okay, $sign comma $sign T1 comma 1. Okay, quickly tell me what is the meaning of this instruction? It's equivalent to what? Quick, dah habis awal ni. Okay, tell me what is the meaning of this instruction? T1 equivalent to
Register T1 equivalent register T1 plus 1.
the T1 plus with 1. Very good. Nama?
Aida.
Aida, very good. Aida. Okay, but the correct answer is not register T1 plus with 1, but it is actually the content of register T1. Okay, but I think Aida is thinking the same lah. Okay, but the correct definition is okay. The content of register T1, it is not T1. Kalau T1 plus 1 is equivalent to T2. Okay, this is actually the content of register T1 plus with 1. Okay, let's say okay. Initially, the content of register T1, okay, register T1 is 2. Okay, okay. After you have performed this instruction, okay. What is the final content of register T1 class? Initially, the content of T1 is 2. After you execute this instruction, what is the final content in T1 class? Tell me.
3.
3. Very good, Aida. Okay, so it is equivalent to the content of register T1. It is not T1. The content of register T1 plus with 1. So you get 3. Okay, so this is the definition, right? Okay, so this is the equivalent conversion. Okay, ADI equivalent to T1. Okay, then this is also T1, and then this is the immediate value. Okay, I believe the previous example you have done it with me step by step. This one should be easy, right? Am I right, class? Betul ke? Description for this one. How to figure out the content of the instruction format. Easy, right? Am I right, class? Please respond. Yeah, because the earlier one much more complicated. This one should be more easier lah. So T1. So what is the value of T1, class? T1 is equivalent to register what? Register T1? 9. Is it equivalent? 1001 equivalent to 9? Betul ke? Correct?
Yes.
Right, very good. Okay, right. And this is the opcode for ADI. Okay, so if you want to refer, we refer to the green sheet. Okay, so quickly go to green sheet. Kita cari ADI Okay. Okay, what is the value for ADI class in hex? You search as well in your green sheet. I have shared the green sheet, right? Okay, are you able to see the green sheet that I have shared to you, class? Ada ke? Class? Ada?
Ada.
Ada. Okay, ADI, add immediate. Okay, what is the hex code for ADI? Tell me.
8.
8.
8. Okay, you can see here, right inside here. 8, right? Okay, so you see here, is it true 8, this one? The value is 8.
Yes.
See, the opcode is, okay, so the opcode is, okay, 1000. It is equivalent to 8. So that is the reason why, okay, that is the reason why, okay, why they have the 8. Okay, are you clear, class? Everybody clear?
Yes.
So I believe you can score the subject, this type of question easily. Okay, right. The following one is the base addressing, also known as indirect addressing, where a register acts as a pointer, right? So it is actually a pointer. So it is a lengthy description, right? Okay, so load word $sign T1, okay, comma for T2. Okay, so we refer to the T2 as the base of memory address. Okay, and then you offset, means that you add 4 memory location. Okay, so the description is, okay, we are actually loading the content of register T2 plus with 4 memory location. Okay, we copy into register T1. Okay, so that's why we have here the content of register T1 okay, is taken, okay, or is being copied from memory location of T2 plus with 4 memory location. Okay, let's say the memory pointed by T2 is 4000. Okay, so if, okay, let's say here, what is that? Okay, let's say, okay, $, okay, T2, okay, the content is, okay, 4004. We are talking about memory location, okay, right? Okay, so when you perform this instruction, okay, so you remember the memory organization that we have learned earlier, okay? So we have a memory location 4004, okay, and then memory location 4005, okay, and then we have 4006, okay, and then we have memory location 4007, and then we have memory location 4008. Okay, let's say the content of memory location 4004 is 1. Okay, for 4005 is 2. Okay, the 4006 is 3. Okay, 4007 is 4. Okay, 4008 is 5. Okay, right? Okay, so now when you are doing load word T1, comma, okay, offset value 4 from the memory location T2. Okay, we know that memory location T2 is equivalent to 4004, right? Okay, so, okay, what happens if you perform this instruction? Okay, for $sign T2, it is equivalent to, okay, 4004, okay, 4004 plus with 4 memory location. Somebody tell me what is 4004 plus 4004 plus with 4. What is the answer, class? What is the answer?
408.
4008. Excellent. Nama. Said.
Saya.
Oh, I cite again. Very good student, Said. Okay, so it is 4008. Okay, so whenever you found this type of instruction, so actually you have to add, okay, the memory pointed by the register T2 plus with the offset 4, then we'll have 4008, right? Okay, so by having, let me using the highlighter. Okay, so by having this instruction, okay, so, okay, when we say load word, actually we are copying the content pointed by the register add with offset value. We copy into register T2. Okay, I've forgotten to insert the value for T1. Okay, let's say the initial value for T1. Okay, T1 is is equivalent to 9. Okay, let's say T1 is 9. This one I put it a little bit further. Okay, right? Okay, now you know that okay, T1 is equivalent to the content pointed by memory location T2. Okay, memory location pointed by T2, which is 4004 plus with 4. So it is equivalent to 4008. So you find out in your memory, where is memory location 4008? Can you find memory location 4008, class? Okay, what is the content for memory location 4008? What is the content? 5. Okay, so refer to this. Highlighter. Okay, 5. So, okay, what happened next? When you know the content of 4008 is 5. Okay, what content of register will change? Which register will change, class? T? Okay, the final one is T1, right? So therefore, the content of register T1 will change from 9 into 5. Get it, class? Okay. Can you see here? Right? So by having the what is that? Okay, base addressing. Okay, the example is load word. Okay, load word. Okay, right. So let's say we have load word $sign T1, comma 4 bracket $sign T2. So actually we are adding the content of register T2 with 4, and this is actually referring to memory location. Okay, so this is actually referring to memory location pointed by T2 and offset. Okay, it is referring to memory location. Oh, sorry, my PC is lagging. Okay, so this is actually the memory location, the memory. Okay, class. Okay, any question? Any question?
Oh,
Clear? Everybody clear?
yes, sir.
Okay, can copy, right? You can copy this one. I give you half a minute to copy. Okay, I give you half a minute to copy the T1 and T2. Okay, so by 1 o'clock we will go on with the following example. I try to finish as soon as possible so that we can go for Friday prayer. Okay, enough minutes. Copy. By 1:01 we will continue. Okay. Okay, kita teruskan. We proceed. Okay, the rest. Okay, same goes to this one. Okay, the arrangement for the instruction format for load word. Okay, also crossing, cross. Okay, so the T1 will be the RT. Okay, okay, and the T2 will be the base. Okay, and the 4 will be the offset. Okay, clear, simple, okay, right? And the opcode for load word. Okay, what is the equivalent hex code for load word, class? Tell me quickly. Load word. Refer to your map sheet. Now I ask you questions so that you know how to refer to map sheet. What is the hex code for load word, class? What is the value in hex? Refer to your map sheet. Load word. What is the hex code? What? Look, wait. This one, right? Okay, what is the value for for load word?
23.
23.
23 or 23?
23.
23, because it is a hexadecimal number, right? So you put it here. Quick. 23. Okay, so you put it here, top, a little bit at the top. Okay, so you put it here, 23. Okay, in hex. Okay, therefore you have to convert to binary lah. So what is binary equivalent? Okay, how many bits for opcode? 5 or 6 bit class? How many bits?
6.
6 bit, right? So we're using 1 0. And then what is 3? 0 0
1 1.
1 1.
1
That's
1.
why you have this number. Okay, are you clear, class? Everybody clear?
Yes.
All right, very good. So this is relative addressing. Okay, example is branch equal 0. Okay. Okay, so this one you can do it from the, you can type it and using the QtSpim. So I think I can show you very fast lah. So where is my QtSpim here? Okay, so this one I have key in the program. Okay, clear the register. Okay. Okay, so if you can see here, my instruction here is, okay, branch if equal 0. Okay, branch if equal 0. Okay, so for my instruction, okay, I will branch equal 0, okay, to the string n. Okay, right? Okay, so in which okay, this one, okay, consists of 12 instruction. Okay, because this is 4 bits. Okay, 4 memory location or 32 bits. Okay, so the another instruction is another 32 bits, right? And the next lah, right? Okay, so it is equivalent to 3 instructions. Okay. Okay, so this one, that's why we have here 3 times 4, we get the 12. Okay. Okay, so this is the one that you type in okay, this is the one that you type in your notepad. Okay, using branch equal 0, go to string n. So this is the branch lah. Okay, go to label. Means that if the result of the instruction is equivalent to 0, you will go to string n. Okay, but the assembler will convert to to 12 what we call as 12 memory location, because one memory location equivalent to 32 bits. Okay, right. Okay, okay, anybody have any final question? I think we better stop now lah, because already Zohor prayer. Okay, so the rest of the lab we will cover maybe next week lah. Okay. I think that's all for today. Okay, till we meet you again later. Okay, class. Thank you to all. Assalamualaikum.
Salam. Thank you, sir.
Thank you, sir.
Thank you,
Yes,
sir.
sir.
Thank you, sir.
Thank you, sir.